Hello everyone. So I'm adding this to today's recording of SI because we had a little mistake with the acid cleavage ranking. Now the mistake was mine because I was using Dr. Roche's ranking. Now, as I talk with you guys, Dr. Roche's ranking is 321 for acid cleavage. But for Dr. West and the one that you guys are going to be using for the next exam is going to be tertiary, primary, and then secondary. Okay, only focus on this unless you're taking Dr. Roche. No. I know that a lot of you got confused because we were confused on the different ranking and also the ranking of the cleavage itself. But in this case, we have an acid cleavage. First of all, you're given an H plus in there, so that's how you know you're doing an acid cleavage. And then, very first step, we know acid-base reaction. We made that OH into a really good leaving group. And now we're comparing a primary versus a tertiary carbon. What's going to be preferred to be cleaved? In this case, it's going to be the tertiary carbon. So that means that we're going to be cutting this bond over here, the tertiary one. Now, after we do that, that means that the stereochemistry of this part, the one that we didn't cleave, is going to remain the same. So that's why we have a dash here. And then we created a carbocation in here. So of course, right now, everything's going to be planar. So that's why I'm not showing the stereochemistry. And then the very last step is just a nucleophilic attack. So that means that our conjugate base from the very first step is going to attack that carbocation and get connected there. And now, in case your professor were to show you stereochemistry, he's trying to test you on this little concept. If you clip, you flip. So in this case, look at how my wedge in that tertiary carbon, my methyl group right there on the tertiary carbon, it's on a wedge. And at the very end, it's on a dash. So that's representing that change in stereochemistry, that flip. Now, usually your professor just gives you the question in planar view, but just in case, it's good to know this, especially for Dr. Roche as well. Now, for the second one, we got that one pretty clear. It was pretty simple. Again, we're also comparing a tertiary with a primary one. Now, remember, first step for acid cleavage only is going to be that acid-base reaction. So, to make that oxygen into a good leaving group. So, after we do that, we are comparing the ranking of the carbons in here. And of course, tertiary is going to have preference to be cleaved over something that's primary. So that's why we have the little carbocation in here. Again, this part, it's remaining the same. It's still on the wedge. I didn't touch it, so I'm not flipping anything. And then at the very end, I'm just going to show that attachment from the conjugate base or nucleophile over here. And then for base cleavage, the ranking for both professors is the same. Primary, secondary, tertiary. So it's the same. Now, the steps are slightly different. We still have the main two components, acid-base reaction and nucleophilic attack, but the order is different. So for base cleavage, we're going to start with a nucleophilic attack, and then we end off with acid-base reactions. So in this case, the first thing that you're going to do is look at the ranking of those carbons. So the left one's tertiary, the one on the right, it's primary. So of course, we're going to try to cleave this one. So to do that, our little base in here is going to be attacking that primary carbon, and of course, it's going to cause electrons to shift to that oxygen. So very last step is to make everything neutral and happy. So our little solvent is just going to come in here. And that's it. So hopefully this clarifies a lot of the questions that we had during the essay session. I know that it was really confusing for most of you. So hopefully this clarifies everything. And again, this is just for Dr. West. We're not focusing on 321. That's just for Dr. Roche. Now, the next topic that we talked about was crown ether. It's very simple. So it's basically just counting. So like we said, the very big number is just going to be the amount of carbons and oxygens that we have. And the very small number is just the amount of oxygens. So that's why in this case, for example, we have 1, 2, 3, 4 oxygens. So that's why we have the 4 in here. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Counting carbons and oxygens only. So that's why we have that big number in there. Now, you're probably just going to get one question on this. I know that most students like this because it's a really easy question to get. Now, in case you're running out of time and maybe you don't have enough time to count every single little atom that you see in there, to find the big number, you can just multiply the small number, so the number of oxygens, times 3, and that should give you the big number in here. Okay? Now, for the very last part of this handout, we didn't really talk about how to solve these questions. I try to make you guys solve it on your own on Friday, but most of you didn't. That's completely okay. Now, I would really get used to multi-step synthesis. They're really gonna start coming around from this chapter until the very end. Now, I'm gonna walk you guys through this. And also, you might see some of these problems on the review for your second exam. Now, very first reaction, multi-step reaction. We have an oxygen, we start with PBr3. We should know at this point that it's from group 1, it's protecting groups. Now, in this case, stereochemistry is not shown, but hypothetically, let's say that we had a little wedge in here. If we use PBr3, at the end, we're swapping that OH for the halogen that we are given. And in here, we would have a dash, for example. But in this case, everything's planar, so I'm not showing that. Now, I have a bromine. Next step is with Mg and ether. Mg and ether always makes a Grignard reagent, so that magnesium is just getting in between carbon and bromine. So that's how we have this little guy. Now, after that, we have our Grignard reagent, and we're reacting with an ester. So we're going to do a reduction. Remember, MgBr goes away, you're left with the nucleophile part. You attack that delta positive, push up the electrons. This is what you form. Then, because we have a leaving group, double bond reforms, we kick out the leaving group. And then, after that, we end up with the leaving group with a negative charge and a ketone, because we reformed that double bond. Now, remember for esters, we have to keep going until we don't see any more double bonds. So, we're going to assume that we have excess, so the Grignard reagent is going to attack again, kick up the electrons, so this time we have 2 rings attached to it. And now, the very last thing that we're going to do is just protonate it so everyone's happy, everyone's neutral. So those 2 oxygens minus are just going to be attacking the water that was given over here. And that's how we end up with this product. So it should be pretty easy to follow at this point. If you have any questions, just send me an email. More than happy to respond to any of those. Now, next multi-step synthesis. We are given a ketone that has a triple bond, and we have the Grignard reagent. Now, in this case, if you don't look at the entire molecule, you might just be tempted to do the reduction with the ketone. But remember, Grignards are very special. If you have anything acidic at all, you're not going to do that reaction. You're going to do an acid-base reaction. And this time you have to keep in mind that terminal alkyne, so that triple bond that has a little hydrogen, is going to be a very acidic proton. So we're just going to be doing an acid-base reaction, which is going to be creating this nucleophile/base. Now, very next reagent is going to be with an epoxide. Epoxides are very reactive in bases and acids. So of course we're going to do a base cleavage. The ranking is 1, 2, 3. So that means that very first step is with a nucleophilic attack. So we're going to be looking at those 2 hydrogens, those 2 carbons. The one on the left, this one, it's primary. The one on the right is secondary. So of course we're going to be cleaving the primary one. And once we do that, we're going to end up with this linear change. Okay, and very last step, we're given water. So of course we're going to protonate, so everything's happy, everything's neutral. So that's how you end up with that product. And keep in mind, this question is testing you on your knowledge on Grignards. Again, if you have anything acidic, you're just doing an acid-base reaction. Unless you're given excess of the Grignard reagent, that was the only exception we saw. And then very last one, it's this multi-step synthesis. And this time they're not asking for the actual intermediates and products. It's asking for the reagents. So keep in mind that. So for multi-step synthesis reactions, you can either be asked for the products or the reagents. Now, whenever they're asking for the reagents, what I recommend is you see the main change. So for example, let's start over here. So we have a secondary alcohol and we end up with a ketone. So that means that I'm increasing the amount of bonds between carbon and oxygen. What was the definition of that? It was oxidation. So after I know that, I'm just going to be looking for the oxidizing agent. In this case, the only one, it's option B. So I'm just going to plug it in here. Now, we're going to repeat the same process with each of those little reactions. Now, next one, we go from a ketone to a tertiary alcohol this time. One of the few reactions that we saw that was able to do that was Grignards. because we're adding an extra carbon chain. Remember, the sodium and the lithium reagent are adding hydrogens. So max, we're only getting like a secondary alcohol. Now, at this point, we're just going to be looking for the greenish reagent now. The main part of the greenish reagent is MgBr, so of course it's going to be option A. Now, next one, tertiary alcohol to an alkene. I'm taking away hydrogens. That alcohol group is acting as the leaving group, so this should sound familiar from chapter 7, an elimination reaction. Now, the only reagent that you're given is going to be H2O with H2SO4. That's pretty much the only reagent you're going to see for elimination reactions at this point, so just keep that one in mind. Now, next reaction, we go from a double bond, an alkene, to an epoxide. We learned this reaction, and it was actually one of the easiest ones that we saw. We don't have to know the mechanism. The only things that we have to know is that double bond plus peroxy acid is going to give you a syn epoxide. So the only peroxy acid is option C, which I know that it's a very long reagent, but yes, you're probably going to have to memorize that entire thing, or sometimes you might see it as just MCPBA, one of those. Okay, so very last step, we are going from an epoxide, and then we have two alcohol groups, so that means that I'm cleaving. Now, we have two types of cleavage for epoxides, acid and base. So, in this case, you have to be really careful. So, first thing that you should notice is the decrease of the carbons in here. So this one is tertiary, this one is secondary. Okay, we got that. Now, to find the actual like acid or base cleavage, you're gonna see at the transformation again. Everything is just by looking at the transformations. So in this case, this bond in here, it's a wedge. And originally, it was a wedge as well. So that means that I'm retaining that one. And then here, the little methyl group, it's on a wedge here at the very product. And then we started with it and a dash bond. So remember, for epoxide cleavage, if you cleave, you flip. So that means that I'm cleaving the tertiary carbon. So the only one that's going to prefer to cleave the tertiary carbon is going to be an acid cleavage. Okay? So that's why we're just going to be looking for an acid in here. So it's going to be option E. Now, hypothetically, let's say that we preserve the stereochemistry of those two bonds. That would mean that we cleave the secondary one. Now, if we cleave the secondary one, we are going to do a base cleavage, which that means that we would have to use option F. But in this case, it's not necessary. So hopefully this little recording can clarify a lot of the questions that we had in the site. Again, I apologize for that confusion. But now you guys are going to be continuing with the actual content that we covered on chapter 13.